In previous video, we talked about the scalar advection equation, and some of the another video we started with the system of first order equations, where we have shown that a q is the vector, column vector containing m elements, and A is the matrix, coefficient matrix. And in previous video, I discussed one scalar equation, partial q by partial x, and then that equation has an application. We discussed that application, partial w by partial t minus, plus c partial w by partial x is equal to 0. In this video, I talked about acoustic equations, a very famous equation in acoustic theory. Here you can see that there are two equations, equation 1 and equation number 2. Now I want to write this as a system of equation with some variables. As you know from the linear algebra, if you have, for example, some equation 2x plus 3y is equal to 10, then 5x plus 10y is equal to 20. You can simply write the coefficient matrix from here, A, 2, 3, 5, 10, your unknown x and y, and your right hand side column vector is 10, 20. That's how we write the system of equation in linear algebra. If I just replace that system of equation with 2 partial x by partial p by partial t plus 3 partial u by partial y is equal to 0, and I write the second equation 5 partial u by partial x, and 10 partial p by partial x is equal to 0. So it is the same equation. So from here you can also write the A, you can also write some other unknown, and so on. That's what we are going to do over here in equation 1 and 2. Let me just write equation 1 as partial p by partial t plus k partial u by partial x plus 0 partial p by partial x is equal to 0. Since there is no partial derivative in first equation, we write it as 0 partial p by partial x. Similarly, for second equation, we write it as partial u by partial t, 0 partial u by partial x plus 1 over rho partial p by partial x is equal to 0. So it's up to you. If you want to write a column vector, you can write it q, for example, q vector p and u from here, and we write the coefficient matrix A. For example, we write 0, then write k, then we have 1 over rho and 0. What is the reason that I have written the coefficient of partial p by partial x, which is 0 over here first? This one is first, then partial u by partial x, which is k. K is, by the way, bulk modulus of compressibility, and we are talking about the speed of sound traveling in the air. So when we have p first, then you should write partial p, the coefficient of partial p by partial x first. And the reason is when we have this p, you can define partial p by partial x and partial u by partial x. Similarly, if we have p first and u second, u as second row, then we can write partial p by partial t and partial u by partial t. Okay, so that's why we have the coefficient of partial p by partial x first. Then we have a coefficient of partial u by partial x, which is k. And then we have again the coefficient of partial p by partial x 1 over rho. And the coefficient of partial u by partial x is 0. So that's what we have over here. Now, we have written equation 1 and 2 in system form. For example, we can write it like this: partial q vector by partial t plus a partial q vector by partial x is equal to 0, where q is defined over here and a is defined over here. So you can see that we have acoustic wave written in system of equation. Now let me just define and make it one equation, one way wave equation, and one way wave equation for left to right and from right to left, something like that. So what we do, we have this equation 1 and 2. I just copy that. Copy. And I paste it over here. One thing we have to remember to write this as one equation, we define C is equal to K over rho under root, and C square will be equal to K over rho, and K will be, which is the same, this K is equal to rho C square. So we just put the value over here, partial p by partial t plus rho c square partial u by partial x is equal to 0. Then we have partial u by partial t plus 1 over rho partial p by partial x is equal to 0. So what we do, we actually multiply the second equation with rho c. We multiply this with rho c. We multiply the same with rho c, so on. What we get from here, rho c partial u by partial t and rho c partial p by partial x is equal to 0. This is equation 3, this is equation 4, and this is equation 5. So we just wrote equation 4 like this. Then what we do, we add these two equations. Partial p by partial t plus partial by partial t rho cu plus adding 3 and 5 rho c square partial u by partial x plus c partial p by partial x. Okay, I can combine these two terms, partial by partial t p plus rho cu plus, and here too I just write c over here, partial by partial x, and take rho c inside of derivative, rho cu plus, and what we have, c partial p by partial x is equal to 0. So what I did, I just added 3 and 5, and then I combine first two terms, and then I can combine the second two terms as well. Partial by partial t, p plus rho cu plus c, we take c as a common, partial by partial x as a common, then we write rho cu plus p is equal to 0. If I define this quantity as w1, since it shows one wave equation, p, then it will be equal to p plus rho cu, and I can write partial w1 by partial t plus c partial w1 by partial x is equal to 0. And you remember from the previous equation, from the previous video, we saw that we had one scalar equation at that time. And this is one wave equation over here. Similarly, if you want to define another equation, another wave on the other direction, so we can have, for example, w2 p minus rho cu, where p is a function of x and t, u is a function of x and t, so on and so forth. The second term, the second equation will become partial w2 by partial t plus c partial w2 by partial x is equal to 0. So we see at the end that two equation has been transported, has been converted, I should say, converted into a, a form like advection equation. One is for right wave and another one is for left wave. Thank you for watching.